Hello, grade 12. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudewa Sos Ukobela Maths. And without any further ado, let's look at this question that we have here. Okay, so we have question 3. It says a ball of mass is 0.5 kg is projected vertically downwards towards the ground from a height of 1.8 meter at a velocity of 2 meter per second. The position versus time graph for the motion of the ball is shown below. Now we are given this diagram below, as we can see. 3.1 says, what is the maximum vertical height reached by the ball after the second bounce? And that is only for 1 mark. So we do understand that when the ball is being projected downward to the ground, it reaches the ground here because they used the ground as reference point. Then this is the ground. It bounces for the first time. So this would be the first bounce here. And then reaches a maximum height, comes back to the ground, and then bounces for the second time. So now they're asking for the vertical height, the maximum vertical height reached by the ball after its second bounce. So that means it is this one here. So our solution needs to be 0.5 meters. Right. Then 3.2 says, calculate the magnitude of the time t1 indicated on the graph, right? And this is 5 marks. Now with a 5-mark question, I indicated to you that starting from 5 mark, then you can be allowed to use more than one formula. So if a question is about 5 marks, then expect that you might be using more than one formula to get the solution, right? So let's go ahead and collect the data here. The V initially is 2 meters per second, as indicated there. And then we are given the delta Y, which is 1.8 meters. I'll be taking my downward as positive since the ball is being projected downward. So I have to have positive 9.8 meter per second square, right? Then I'm looking for delta T. I do not have that. But then again, what I do not have is the final velocity. So now looking at this data, we can see that we have 2 unknowns. For a 5-mark question, I can start by looking for the V finally, then pick a formula that has delta T so that I can calculate time T1 there. So time T1 has to be for the first part here when the ball is still being projected downward and then reaches the ground for the first time. Okay, so let's decide or agree to use the formula VF squared is equals to VI squared plus 2A delta Y. So I'll be using this formula here to find the V finally. So this is VF squared. My V initially, that's 2. And then here I have positive 9.8. Then my delta Y is positive 1.8. Right. Now punching all this into my calculator, I have VF squared is now equals to 39.28. Right. Then if I square both sides, then VF has to be equal to 6.27 meter per second. Right. Now that I have my V finally, let me include it here. So 6.27 meter per second. Right. So that means I can use now the V finally to calculate the delta T by using another formula. VF is equals to VI plus A delta T. So substitute 6.27 here, and then V initial is still 2. Then I have the 9.8 and then delta T. Now at this point, I only need to transpose the 2 over to this side. So 6.27 minus 2, that's 4.27, and then equal to 9.8 delta T. If I divide both sides by the 9.8, then delta T is equal to 0.44 seconds, right? And just like that, I would have my solution. So this would suffice for 5 marks, right? Because I've used 2 different formulas. So probably I get 3 marks for this one and maybe 2 marks for this one. So it makes sense. But then another learner could have just used a different approach to say, okay, I do not mind not having the VF So let me just erase everything. Another learner could say, yes, I have my V initially 2 meters per second, and then my delta Y is 1.8 meters. And then I also have A, which is positive 9.8 meters per second square. And then now I'm looking for delta T. So another learner could just say, yes, I do not have VF. So I'm just going to refrain from any formula that has V final. Now, the formula that they would use is this one. Delta Y is equals to VI multiplied by delta T plus half A delta T square. Right. Now, the delta Y is 1.8. The V initial is 2, and then multiplied by delta T plus half. Here we have 9.8. And then delta T square. Right. Now, you do understand that the learner here would now have a quadratic form equation like that. And then to calculate delta T, they would now have to use the quadratic formula. So that's negative B plus, and then B squared minus 4AC over 2A. Now, looking at this, we can see that our B here is 2. So substitute the 2 there. And then again here, substitute the 2, and then it's square. Now, the A is 4.9, but C is negative 1.8. And then all over 2 times 4.9. Now, we know that with the quadratic formula, two solutions will be produced, which is the first one is 0.44 seconds, and the other one is negative 0.84 seconds. Right. Now, we do understand that we cannot have our delta time as a negative because time is only a scalar. It does not have direction. So we have to come back here and cancel off the negative value. So we are left with 0.44 seconds, which could have been option number 2 to answering the very same question on 3.2. So you had 2 options to answer that. So even this one here would give you your 5 marks, right? So either way, there are many ways to kill a cat. Whatever option that you understand, please fly with it. Then we have 3.3. It says, calculate the velocity with which the ball rebounds from the ground during the first bounce. Right. So we do understand that here the ball will be falling all the way from that height of 1.8 meters and then reaches the ground. It is in contact with the ground for a little while and then bounces off. Right. So the velocity that we are being required to calculate here is the velocity with which this ball leaves the ground. So rebounds means when it now leaves the ground, right? So we are calculating the velocity with which the ball leaves the ground, right? So that means if we have to consider part number 2 here, going all the way from the ground to the maximum height, then we would say that our V initially, that's what we are looking for. But the V finally is 0 meters per second, since when the ball rebounds, it reaches the maximum height. But then looking at this, we can see that we are given that the maximum height there is 0.9. So we have our delta Y as 0.9 meters. But if we are to consider our positive direction as downward, so if we are to consider excuse me for that. Then if we are to consider that initially we chose downward as positive, then we have to understand that our delta Y now needs to be negative 0.9. Why? Because remember, if we chose downward as positive, but our ball is going upward, then that means our delta Y is negative. And then also again, the velocity that we'll be calculating there will come out as negative, right? Why? Because the ball is going upward, but we chose downward as the positive direction. So it is opposing the motion that we chose, or the side that we chose as positive, right? Hope I make sense there. Then A is equals to 9.8 meter per second square, right? Then we are looking for VI, so we can use the formula that goes VF squared is equals to VI squared plus 2a delta y, and then the VF is 0, so substitute there, 0 square. Then the V initially, that's what we are looking for, can substitute positive 9.8 here, but then right here we'll have negative 0.9. So be careful of that. Then this is 0 VI squared. The answer that we get from this one is negative 17.64, which if we transpose it over to this side, this is positive 17.64. And then we square both sides, then our V initially becomes, punch that into your calculator, it's now 4.2 meter per second. But since we chose again downward as positive, that means our velocity needs to come out as a negative, because remember, if the ball is going downward, if the ball is going upward, meant to say, and then we chose downward as positive, then our velocity comes out as a negative. So this obviously means that VI is 4.2 meter per second. To which direction? Upwards, right? So note that we need to indicate the direction because we are calculating the velocity. Velocity there is a vector, so it must include both magnitude and direction. So for 4 marks, that's what you needed to do there. So I believe the extra mark there is for indicating the direction. Okay, so for 3.4, we have a statement just above 3.4 there, which relates to 3.4. So be careful of that. Make sure that you read the statement there. The ball is in contact with the ground for 0.2 seconds during the first bounce. So this is telling us the difference between T1 and T2, which is this indicates the contact time with the ground. So we are told that it was 0.2 seconds. Now 3.4 says calculate the magnitude of the force exerted by the ground on the ball during the first bounce if the ball strikes the ground at 6.27 meters per second. Right. So we can see that this is a question on impulse, right? So make sure that you find that relationship between VPM and momentum and impulse as a topic, because they always find a way to just merge it into your VPM topic, right? So always make sure that you are alert of that. Then now, if we are to use this formula, the impulse momentum theorem, we have F net delta T is equals to change in P. So if we are just to consider the horizontal movement or motion between T1 to T2, you will note that in 3.3, we were actually calculating the velocity with which the ball leaves the ground, which is the velocity at exactly this point, T2. And then we found that it is negative 4.2 meter per second. So we do understand it was negative because it was going upward, and then we chose downward as positive. But then from this statement here, we are being told that the ball strikes the ground at 6.27 meters per second. So it strikes the ground coming from above, meaning it was going in a downward direction. So our 6.27 here is positive, and it indicates the velocity at time T1. Right. So now we have two velocities. That means we can now use the formula here, break down the change in P. This will be F net multiplied by delta T is equals to mass, velocity finally, minus velocity initial. So we are given the contact time between the ball and the ground is 0.2. And our mass here is 0.5 kg, so it is in the desired SI unit, but our final velocity will be the velocity with which the ball leaves the ground or rebounds from the ground. So this is negative 4.2, and our initial velocity is the velocity with which the ball strikes the ground. So that is 6.27. So now to calculate our F net, we simply need to punch all this into our calculator. Then we find a value of negative 5.235, which we'll then need to divide by this 0.2 here to find the net force. Now our net force is equal to negative 26.175 newtons. So we do understand that the negative here indicates that the ground will be exerting an upward force on the ball. So remember, according to Newton's third law, when ball B coming from above exerts a downward force on the ground needs to exert the same magnitude of force, but in the opposite direction. So meaning it's exerting that force in the upward direction. Hence we have this, right? So that means F net is now equals to 26.175 newtons, right? So we are indicating it as a positive because remember, they just say calculate the magnitude. So they're only interested on the magnitude and not the direction. So we just deal away with the negative because the negative is indicating the direction. Note that. So, okay, that's how you would have your net force for a total of 4 marks. So make sure that you check my approach there. If you have to pause the video and try to understand, please do so. Then let's move to 3.5. 3.5 says, draw a velocity time graph for the motion of the ball from the time that it is projected to the time when it rebounds to a height of 0.9 meters. So that means we are drawing a velocity versus time graph indicating all this motion up until this very point here, right? So this is our end position here. Now, to draw the graph, we obviously need to first indicate our Cartesian plane like that. So we have it like this. Now let's check what we are required to show. It's the time when the ball hits the ground, the velocity of the ball when it hits the ground, the velocity of the ball when it rebounds from the ground. And that's exactly 3 marks. So they were kind of stingy with the marks, but you know, it is what it is. Now, okay, remember we chose downward as positive, so that means I must have an increasing function. So starting from my initial velocity here, the ball will be increasing in velocity since it's going upward until it reaches the ground. So it reaches the ground at time, we calculated that already. Remember, time t1 indicates the time where the ball hit the ground. So at 0.44 seconds, right? And then the initial velocity in which it was projected downward was 2. And then the velocity with which it hit the ground, we were told that it is 6.27. So note that when you fill in your velocity time graph, it will not be with values that you haven't calculated already. So everything that you are filling in into your velocity versus time graph is already a calculated value. So note they told us that the ball is in contact with the ground for 0.2 seconds. So that means the ball does not leave immediately after it hits the ground, but then it stays on the ground for 0.2 seconds, meaning it leaves the ground at time 0.64, right? Because it stayed on the ground for 0.2 seconds. So this is time t2. The 0.64 is time t2. Then we do understand that since this is an inelastic collision, the ball will now be leaving the ground with a velocity that is lower than the velocity in which it strikes the ground. So this would be the velocity there. And then when it rebounds, it goes to the maximum height, right? So our journey stops there on the maximum height, according to what they want us to represent. But then what is the velocity here? The velocity at which the ball rebounds from the ground. We calculated that velocity again, and then is the one that we found that it is equal to 4.2. So the one we were calculating here in 3.3. So negative 4.2. Negative 4.2. So yeah, that's negative 4.2. So I hope it's visible enough. Then there we go. So it reaches the maximum height. So remember, at the maximum height, the velocity is equal to 0. So that's all that you needed to indicate. All that's left to do now is to label your axis. This is time in seconds, and this is velocity in meters per second, right? So to tell the story on this, the ball was projected upward. The ball was projected downward at a velocity of 2 meters per second, and then it went all the way down to the ground. So this is the ground. Do not be confused by this, guys. This does not indicate that the ball went upward. This is just indicating that as the ball was going downward, the velocity was increasing. Remember, when the ball is going downward, its kinetic energy increases. So from a velocity of 2 meters per second, the ball goes all the way to the ground and hits the ground at a velocity of 6.27 meters per second. But it stays on the ground for 0.2 seconds and now leaves the ground at a velocity of negative 4.2 meters per second until it reaches the maximum height at a velocity of 0. Right. So I hope that makes sense. Now, that's it with the lesson today, guys. Please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.